Sad je prekinuo, ali... Ok, izgleda da neće. Ako nas prekine, je bio.
Sad nisu. Ja ću naslika što?
Dobro večer. Prvo, dobrodošli ste svima koji ste došli, malo je kiša i hladno i tako dalje, hvala vam. Samo da najem da ćemo pričati ipak na engleskom, nadam se da nije problem, pretpostavljam da nikome nije, pre svega zbog naše kancelarije u Ljubljani, da bi oni mogli to da razumiju, ne znam da li inače ima nekog drugog na streamu koji ne razume srpski, tako da pređem na engleski. Hi everyone, welcome here both on the stream, especially to our colleagues in Ljubljana, if you have some. But my name is Petar Vucelja. I'm a Director of Software Development here in United.Cloud. And this is second in our series of tech meetups, but for me, very special. And personally, I'm very much invested in this topic because part of my role is primarily to let's say, most effectively realize business goals, which means having something like this. You'll see more details about Backstage, and generally internal development platforms, internal or otherwise, directly helps that because it reduces the amount of time spending on, let's say, infrastructure, quality parts. We need to maintain quality, that's a given. We need to maintain standards, but doing it quickly, automatically, makes our development much faster. And what is also very important in my role is that people, since I lead primarily product development teams, people doing this don't invest so much time in repetitive infrastructure boilerplate tasks. I'm not saying that all infrastructure tasks are boring, but when you need to repeat them 30 times every couple of months, it doesn't make sense. They can invest their time understanding the business, understanding the domain, and be much more motivated. So far, we've had excellent results with Backstage, with help from our great colleagues Petar and Vojislav, and that's about it from me. Basically, I'm the primary stakeholder, and I'm very happy that we are realizing this initiative. So I'm handing it now, I guess, to Vojislav, right? Or okay, thanks, guys.
Okay, so I'm Vojislav. I'm Technical Excellence Evangelist for CI/CD at United.Cloud, and tonight Petar and I are going to tell you about some issues we faced in our scaling organizations and how we fix them. And during our talk, please feel free to ask questions, just raise your hand or interrupt us at any moment. So first, for some context, in 2018 we had about 30 developers in 6 teams, all working on one product. Now, 6 years later, we employ over 350 people in 32 teams, and we are working on 13 different products. So obviously some things that used to work back then don't work that well right now. 6 years ago, our first release to production was a bit rushed because we had a hard deadline for hitting production, and everybody was doing their best, but as an organization, we did not really follow best development practices. So after the initial deployment to production, we did deploys once every couple of months. And days that we did deploys on were the most stressful days at work. Because after each production deployment, we had production issues. We either had to do revert or hotfix. We always had some downtime. So our clients, telco operators, wanted us to do deploys even less frequently. They wanted to push us to do deploys only once a year, because from their perspective, each time we do deploy, they have downtime. So if we do deployments less, they will have less downtime. Of course, in software development, that kind of thinking does not really work. In our line of work, the saying is, if it hurts, do it more often. So our goal was to deploy to production once every 2 weeks or after each sprint. So what are the benefits of these often deployments? Well, the number of changes deployed to production are number in size. So there are less things that can break. It's easier to validate a successful release. It's easier to revert it. It's easier to troubleshoot it and fix it if it comes to some problems. So what are the problems that prevented us from deploying this often? Well, first, our deployments were manual. We had a very delicate process with manually copying files on multiple servers. So we would end up in inconsistent state of our deployment, where we push one configuration on one server, we forget to do that on the other one. So we ended up with creating a flight control-like procedure for deployments, where each deployment required at least 2 people, and one person would announce the action they're gonna take, then the other person would validate if it's okay to do it. They would say, yeah, okay, now go deploy, and so on. So very delicate manual process, very error prone. And this was not sustainable for often releases. So we realized that we had to automate our deployments. How we did it? Well, we did it very easily. Because our DevOps team just took away our write permissions on production servers, so we could no longer do that manually. They written some Ansible scripts that we could run, and we started doing deployments like that. Those scripts at the beginning would usually fail. They were very shaky, but after a few releases, we patched those things, and we had automated deployments. Another problem that we had was that we had no automated test. On some projects we had them, but quality of those tests was not great. And we were spending a lot of time of manually validating each release. So if you're going to release once every 2 weeks and spend 2 days validating each release, the cost of testing is just too high. So we had to automate our testing. To validate those tests, we introduced static analysis on each build. We set a quality gate for new code to have at least 80% of test coverage, and we slowly started to build more and more tests. One disclaimer here, test coverage as a metric is not sufficient in itself. You can have 100% code coverage, and that does not tell you anything. Your tests may still be very much useless, even if they cover 100% of code. But this metric is actually useful if it tells you that you have low code coverage. If it tells you that 50% of your code is not covered by tests, well, then that is a very useful metric. What happened next? Well, we started to deploy once every 2 weeks. Our deployments got easier and easier. We actually start to like doing deploys to production. We would actually get nervous if we had to miss some deploy to production, and we wanted to do it as often as possible. So at the time, we had a monolithic system, and as our organization grew, number of teams that commit to that monolithic system started to grow. And we had to coordinate those teams when it comes to deploys to production. because maybe one team had a critical fix or a shiny new feature that they had to push to production as soon as possible, but other team committed some code that was not production ready, and that actually had to delay the critical deploy to production. And this starting to happen more and more often as more teams started to commit to our monolithic system. So our solution was to this was transitioning to microservices architecture, because microservices are a solution to organizational issues and not technical issues. So when each team became responsible for their own service, each team could deploy their service whenever they liked it, and that solved our problems with coordinating between the teams. But with microservices, we started to hit new problems. We did not have a proper infrastructure to support our transition to microservices. So how creating a new microservice used to look like? Well, developers would first start to develop the microservice on their local laptop. And they would do so for, let's say, about a month. And after a month, they would remember to open a DevOps request for them to create a testing environment. And then DevOps team, based on their schedule, would either do that right away, or maybe in a week, or maybe in 2 weeks, and even further delaying deploying to test environment. And that's really problematic because some issues can only be seen only once your service is deployed to a production-like environment. You can't do proper performance testing on your laptop. You need a production-like environment for that. You cannot simulate latency in inter-service calls on your local laptop, as well as you're going to see that those latencies on a real production-like environment. So it is extremely valuable to have your service deployed somewhere as soon as possible. Also, another problem is we started to create more and more microservices, and we started doing that very often, but still not often enough for people to be able to do that on autopilot. Developers would usually spend between 1 day and a week just creating up a very simple hello world service, because they had to create and configure Git repository, create a continuous integration pipeline, Docker image, set up static analysis, create Kubernetes manifests, and so on. And that was a very mundane, boring, repetitive process. It was manual, and it was very error prone. So how did we end up with such cumbersome process? Well, let's go back 6 years ago when we had 6 teams. Back then, our DevOps team gave us Jenkins and Nexus, and each team was tasked to create their own build and deployment process. And that strategy was okay back then, because each team knew their technology stack and they could build what works for them. The problem is that for when the other teams came, when new things started to arrive, they faced the same issues that the original 6 teams did. But there was no good communication between the teams. There was no code reuse between the teams. So new teams faced the same issues, and they solved them differently. And the problem with this is that for most of the teams, things like CI/CD pipeline, their build processes was just an afterthought. So we ended up with like 3 or 4 ways to just build and deploy a very simple Java Spring Boot application. And that really started to cause problems that I explained, that developer, when they need to create some new service, they do not really know what they have to do. So we realized in order to alleviate these issues, we had to create some standard. We had to standardize the way that our software is built, developed, and deployed. Because we want to be sure that we have good practices baked in from the start. We need to be sure to have good code quality, have high test coverage, that good security practices are implemented, and that we have highly available deployments. So, our first step was to create some templates. We created a sample Hello World application, created a sample CI/CD pipeline, and we created a Kubernetes deployment for that service. But the problem was that this was still a manual process. Developers now had templates, but they still had to do all that work that they already did. And another problem was developers were actually very reluctant to change. They already had something that worked for them, and they would mostly agree that the new templates were better than what they already had, but they did not see any value in switching from something that already works for them. So, in order to actually give some benefits to developers, we created some libraries from those templates. So, first we created a library that integrates your service with our monitoring, logging, and alerting infrastructure. So now when you create a service, include this one little library, and you have free Grafana dashboards, you have free centralized logging, and alerts. Second thing we created a pipeline library. So developers do not have to write their CI/CD pipelines for each project. They could just reuse them from the library. And there are two ways to create reusable pipelines. We are using Jenkins, but most CI platforms support both of these ways for using code. So we have composable pipelines and we have reusable pipelines. Composable pipelines are made of set of common stages. So in one library you would define some common steps, common stages, and then developers, when they're creating their own pipelines, can just pick and choose from those stages that they want to use. So, pros of this solution is that this is very flexible. As a developer, you're free to choose whichever stages fit your needs. But the problem with this solution is if we want to, for example, add a new stage into all of our pipelines, we want to add a new security analysis in each and every build, then we need to do that in all the pipelines. So another option is to create reusable pipelines. To create a pipeline, entire pipeline in a library, and then developers would just call pipeline from the library with their own configuration. So what's good about this approach is that all the code of all the pipelines is managed in one place. So when we make a change, when we, let's say, add a new security analysis in our pipeline, all pipelines for all services get that for free. What are the cons of this solution? Well, it's very rigid. You can only call defined pipelines. If you want to add some specific stages, or you don't need some stages in your pipeline, you have to make changes to the central repository. And that becomes very difficult to maintain because the pipeline from the library becomes very complex to accommodate the needs of all the services that use it. So, which solution did we choose? We chose the best of both worlds. So we created some common set of stages in a library, and on top of that we created some reusable pipelines. Because most of the services we create are standard web services that are all built and deployed the same way. So 90% of services can just reuse predefined pipelines. For those special cases that need something different, we left them with a choice to just use the stages they actually need and add some custom logic. We did similar thing with Helm charts. There are two ways to create a Helm library. And it's basically the same as in Jenkins. You can extract only common pieces of logic from your Helm chart and then reuse those pieces in your chart, or you can create a reusable chart and just in your deployments define a special values file that will configure that deployment for you. So in case of Helm charts, we decided to go for the first option. We just extracted some common pieces of logic from our deployments, and we can reuse them in our Helm charts. Why did we use that solution? Well, because YAML, writing valid YAML in Kubernetes is already difficult in itself. And with Helm, you add entire new programming language into YAML files, and maintaining that was very difficult because your reusable chart needs to handle all of possible cases. That chart becomes very complex very fast, and when you're writing values files, you do not even get help from your IDE like when you're writing standard Kubernetes manifests. And now when we implemented these libraries, gave them to developers, adoption of the new way of working, of new standards actually started to get higher, because developers actually saw benefits in reusing these libraries, in reusing pipelines, in reusing Helm charts, because they no longer had to maintain that, or if they had some changes, they only had to make changes in one place. What really drove adoption of the new standard is the Backstage. What Backstage allowed us to do is to automate all those boring steps, all that manual work. So now developers only have to fill a simple form, and they get Git repository, they get CI/CD pipeline, they get their service deployed to testing production instantly in a matter of minutes, and job that used to take from 1 day up to a week, maybe even more, with Backstage we automated it to a few minutes. And now Peter will go through the rest.
Hi, I'm Peter. I'm SRE engineer at United.Cloud, and I will explain the Backstage part. So what is IDP and what is Backstage? And IDP stands for Internal Developer Platform. It's a tool built by the platform engineering team to provide it to developers. It provides developers with self-service for infrastructure, golden paths, and something called the service catalog for the resources within the organization. How does it look? It can be an API, it can be a CLI, it can be a web portal, and you don't have to pick and choose. You can use any and all of these in combination. Backstage is an open source framework for building developer platforms. It's important to stress the framework part. Out of the box, it comes with a software catalog and templates which serve as the golden paths. At United.Cloud, we have several ideals we are striving for. We want our teams to have independence, to be agile, to have declarative infrastructure, to easily discover resources, and to have self-service. We already have a strong DevOps as a culture implemented in the organization. We use standard agile methodologies for development, and we use trunk-based development to keep our dev cycles short. With various in-house tools and scripts, as well as the established tools such as Ansible and OpenTofu, we are striving to have a declarative infrastructure. In order to achieve greater discoverability of resources and better self-service, we have turned to Backstage. From an SRE point of view, I have different kind of problems than developers. Since the number of microservices exploded, it has become a detective work to find out things in the system. And oftentimes I need information such as where are the monitoring dashboards for this service? And we have over 1,500 Git repositories spanning 100 Git organizations. So where is the repo I need? Where is the documentation and where are the pipelines? This constant reverse engineering to find out information is a great cognitive burden on both DevOps and developers. With Backstage, I have all these informations at the tip of my fingers. And let's see a basic flow I can experience now, or any developer in the organization, when getting familiar with the new service. The first thing I see is our inventory. It's a software catalog. When I click on a particular service in an inventory, I can explore a bunch of metadata. For example, I can view the source repository. I can navigate to documentation which is integrated into the view with this service. I can also view CI/CD status and some basic metadata for the CI/CD pipelines. I can jump straight to Jenkins if I need to debug a pipeline or inspect a pipeline. I can even view the API the service provides or consumes, and I can explore that API interactively. I can view the status of the service across Kubernetes clusters. For example, the errors are displayed first, and I can even explore manifests of deployments, stateful sets, pods, and I can even look into the basic logs of any pod. When I get back to the main view, I can see a link section, and in the link section you can put any relevant link. For example, we put usually monitoring dashboards in the link section, so we can quickly access metrics for the service, such as CPU, memory, or any other relevant metrics for the service. Since Backstage is a framework, you can customize this framework to your needs. We use Jenkins because we use Jenkins, but you can also integrate it with GitHub, GitHub Actions, AWS, or any service that your organization is using. With relationship diagram, I can see resources associated with components or with the service. For example, here is my service, and here are the APIs it provides on the left side, and on the right side, the API it consumes and the infrastructure resources that the service is using. We can see that the service is using an S3 bucket, it is deployed on a Kubernetes cluster, and it's using the Git API. On the other hand, I can click on the API the service provides. And when I click on the API the service provides, I can see if there is any service within the organization which is using that API. And of course, when I click on that and on that service which is using the API, I can explore its relationship further. For example, one of the interesting things on the relationship diagram is the owner. And when I click on the owner, I can see everything that is associated with the given owner. If I need information about the service owner or who to contact, I can go back to the main view and click on the owner, and I can see the whole team and choose who to contact if I need to. Since there are a lot of technologies that we are using, we try to make the best of the tech reader, and this handy tool comes out of the box with Backstage. And if I'm thinking about new service and starting a new service or using a new tool or language, I can turn to Tech Reader to see which technologies we have adopted in the organization or are currently assessing, or even which technologies were rejected. When I click on a language that interests me, I can see the complete history that led us from initial assessment through trial and adoption. I can even put links to any relevant documentation to help me get on board with particular language, tool, or service. With this rich metadata provided through Software Catalog, we give our developers an easy way to discover resources within the organization, such as repositories, documentation, databases, caches, etc. Now let's turn to the last requirement we wanted to achieve. The second set of problems I have is automating tedious tasks. DevOps teams are always struggling with a lot of operational boilerplate, especially with all the boilerplate that comes with a new service. For example, when we make a Kubernetes namespace, we also need to make proper service accounts, roles, permissions, distribute service account tokens, and for example, we need to enable communication between Jenkins and Kubernetes. We need to maybe configure new Git organization, make a new Harbor project, or SonarQube permission templates. Since we already have a strong culture of self-service within the company, it is realized through self-service Git repositories. The first thing we did was to tie all our existing self-service repositories into a single view. We strive to use Backstage as the aggregator of our existing tools. And for example, this page that is shown on the screen is a simple UI plugin in Backstage. You can build it with React, and it's almost like building any single page application. You can customize it to your need, whatever you like it. Templates are something that can be built by any team within the organization. Even at SRE, we have a lot of templates for Python, Golang, and the services we use to automate stuff. Let's see how a service is actually made from the template. And this flow, which I will show now, is the flow the developer will also use when making a new microservice. First, I would select the template, then fill in the form. I can use various drop-downs to select, for example, Git organization, Harbor project, Jenkins folder, etc. After the form is finished, template actions kick in and make the Git repositories, push project files, make Jenkins pipelines, and provision Git webhooks. After that, the standard CI/CD kicks in and deploys the application to our Kubernetes clusters. And you can go to the software catalog, to your service, and choose the Kubernetes tab, and it will show up in the Kubernetes tab, and you can follow the progress there. Templates consist of two important parts. The first part is template configuration file. It's a YAML divided into two main sections. The first section of a template defines the parameters the user should input. These are the inputs that developer is filling in the template form which was shown previously. The second section is a set of steps to execute. For example, create Git repositories, import service into the service catalog. These are the so-called template actions. Template actions are similar to CI/CD. As you have seen on previous slides, you define a step-by-step script which describes what needs to be done. There are a lot of built-in template actions which you can explore at any time in your Backstage instance. These actions help you interact in various ways with GitHub, GitLab, Bitbucket, most Git repository providers you have. You can even develop your own actions. Since we are using Gitty as a Git source solution, we had to make our own actions, and making actions is fairly easy. An action usually does one thing and one thing only. It acts like a small script which glues together with other scripts through configuration in a YAML file. We can see on the screen an example of a custom action. It consists of two parts: the input that goes into the action and the script itself. In this case, this is an action that creates a file on a file system using a given input from the user. By tying our existing self-service repositories and making them available through Backstage, and by adding software templates, we've achieved better self-service for the teams. Now let's talk briefly about the architecture of Backstage. Backstage is comprised of plugins. Almost everything is a plugin in Backstage. We have core UI and core backend. And in addition, we have UI plugins, which can be static, proxy, or plugins with backend. Backend plugins are another type of plugins. They can be standalone or even new template actions. And plugins can have their own databases. Proxy plugin is particularly interesting because we can write a simple UI component for a third-party API just by proxying the requests. We use this extensively for various purposes. One of the purposes being our drop-down menus in the template, for example, to proxy actions to Git or to Jenkins. It goes through the proxy server and straight to the service. Backstage has a rich ecosystem of plugins, mostly third-party plugins for Jenkins, various AWS plugins, Datadog plugins, GitHub plugins, Argo CD plugins. But there are also notable built-in plugins such as TechDocs and Kubernetes plugin. Since we already seen a lot of pros, what are the cons that needs to be considered? Since both developers and DevOps had a similar set of problems, we needed to approach these problems from two different angles. Backstage proved to be a good common ground to join forces. Therefore, we needed at least 2 people to implement Backstage. Voislav worked on automation of the templates, and I integrated Backstage with various systems. In total, we needed around 6 months to plan and develop the solution. We have to keep in mind that Backstage is a framework and not a ready-made solution. There are a lot of ready-made solutions for IDPs, but they all come with a hefty price tag. We strongly lean on an open source, so we wanted something which is extensible and can be integrated with other tools. For example, Backstage has very limited integration with Git, so we had to write our own integration. However, if you're using GitHub or GitLab, you can cut the development time. Backstage also requires a skillful team. It needs knowledge of full stack development and basic understanding of infrastructure tools. We also had to write a lot of plugins for Backstage. In addition to third-party plugins we are using, we also developed 11 custom plugins of our own. For example, the drop-down menus are a plugin, and the template actions are another plugin, and so on. Once we implemented the Backstage, there came the problem of maintenance. Upgrading to a new version is the same as when upgrading any code base to the most recent version of libraries. Parts of the code need to be changed, refactored, dependencies may break your custom integrations, and some libraries may be completely out of date. But we strive to upgrade the Backstage every several months, and luckily there is a detailed upgrade guide provided by Backstage itself. To overcome these challenges, we need to get constant feedback from developers, treat developers as customers, and treat IDP as we treat any product within the organization. Because all of this, an organization usually needs to have some size and maturity to it. Sometimes there are dedicated developer experience teams. For us, we are at the moment in our organization where we need to standardize our tech, automate operational tool to free DevOps and developers from wasting time on boilerplate, and where we have enough skills to develop and maintain Backstage. And finally, we have some open-ended questions and a lot of ideas for future development. Enriching our self-service menu is an obvious one, but we also want to implement better metrics. We want to make sure to have measured adoption rate, mean time to pull requests, to merging pull requests, track deployments to production. We want to have better correlation between our microservices and databases, Redis caches, buckets, etc. In order to onboard developers to Backstage, we plan to ingest all repositories and add automatic service discovery for all new and existing Git repositories. At United.Cloud, on the inception of the service, we have various service deployment procedures, or for short, SDPs, which ensure that all teams are on board and all best practices have been followed across all teams. There are SDPs for SRE, InfoSec, and so on. For example, an SRE SDP answers questions such as, is this service highly available? What are the storage needs for this service? Are database migrations automated? At the moment, the review procedure is manual, but with Backstage, we plan to automate it as much as we can and ensure that service comes with these out of the box. So, thank you. Do you have any questions? Maybe a couple of minutes to think about questions. Yes.
Anybody?
Uh-huh. So you said your software is open source. Do you have a link
No,
to your
Backstage is actually developed by Spotify. So we are using the Spotify's project. Our own integration is not open source, of course, but you can just
Might use some common to open source some common things, but
yeah. So you can just Google Backstage. I think it's Backstage.io, and it's like starting any project with yarn npm and just installing the library. And it's a framework, so you use the libraries provided by the framework to build your own portal like this.
Thank you.
Okay.
so there's beer.
Yeah.
Yes.
Thank you very much.